So the first one is the Rossman store sales. So it's a drugstore in European countries. And in their data, they have about 1,100 stores. And then the task is to predict the daily sales of the stores for up to 6 weeks in advance. And along with the data, they have many additional factors that can affect the sales, such as the promotion, competition, holidays, et cetera, right? So I think their data set is also very interesting to incorporate all this additional information for the sales. So here's a more detailed introduction to the data they provide. So the first is the historical sales, right? So you know a store, which store is that, at what date, and you have the sales, that's the forecast or predicted variable, right? So what's the sales of a given day within that store, and also how many customers come, and whether the store is closed or open, and then there's also the state holiday and school holidays. I think so the holidays can affect the sales, right? So it's good that they provide it along with the data. And then for the so this is more on like each day, each store, how many sales and customers. And then they also provide the metadata for the stores. So they have mainly 4 stores, different store types. And different assortment. They also provide some competition of where the nearest competitor store is, when that competitor store is open, and also whether that store is running some promotion. Right? I think it's also very important to boost the sales if there's a promotion of certain items. So all of this is about different promotions information. So that's the data. And then what's the metric? Because for the Kaggle competition, they usually publish a metric that can automatically evaluate your submission, right? And then you will get a score on their public leaderboard during the competition phase. But in the end, you are going to be scored in their private leaderboard. So the private leaderboard, the data is kind of closed during your training phase. You don't know what data or the data is not disclosed until the end of the competition. So, well, that score, they use this metric is the root mean square percentage error. So this is more like a relative error. It's not, I think we are all familiar with the root mean square error, right? So that is basically without this division here. So this is like the differences divided by the absolute values of the original values. So this way, because different items can have different amount of sales, and you kind of normalize the errors in this way. So it's a squared of percentage errors. Okay, so let's look at some winning solution. Well, the first one, I think the author documented pretty well. So it's mainly with lots of feature engineering. You see this competition, I think it's 6 years ago, right? So I guess at that time, the neural network is still not as popular as nowadays. And also the model is not as fancy as nowadays. So I think most people will spend lots of time on the feature engineering. I think even now, the Kaggle competition will still require lots of feature engineering. I think that this, the first place really has done a great job in the feature engineering. So what features did he generate, right? So there are many 5 categories. One is on more recent data, one is on temporal information, and also he extracts some trends, like model the trends, linear trends in the data. And of course, he used the store metadata, right? So the store types, assortment, etc., the competition information, etc. And then also some additional data, external data sources about the weather, like on that date, whether it's hot, what's the temperature, and what's the rain, whether there's a rainfall over there. Yeah, and this is a new well, he published the feature extraction. So first on the recent data, so it's basically first you need to get a group of transactions. Right? So the group, well, you can group the data by these keys, right? Either by store, by day or week, by whether or not they have that promotion, and by holidays. So you can group by the data with these keys, right? And then you have many, many different groups. And then within each group, you extract certain time period from that data, right? So you can just grab the previous months. So for all the data point, you can get like all the previous months, last quarter, last half year, etc. if it exists. And then for each of the extracted time series within that group, you calculate lots of stats for that time series, right? Such as mean, median, deviation, skewness, percentiles. So he basically generated lots of stats for all these different time series within each of these groups. Yeah, so yeah, you can see the amount is huge after you combine the combination. This is more on the recent data, the statistics about on the recent data, the recent time period. And then there's some temporal information on the day counters, right? Because the data provide the holidays and events. The events including the promotions, holidays, whether the store has refurbishment, and also the competition or promotion cycle, right? So you can actually count for a given day, you can count the number of days before, after, or within the event. So you can tell that day whether it's during an event, is how many days before, how many days after. And so this kind of tells some more correlations with the events. And of course, within the date, you can extract like day of week and all these time-related features. And then you can even count the number of holidays during current week, last week, and next week. So it's like, I think it's another round of stats regarding to the events. And then the trends, so they propose to use, according to the documentation, I think they train a store-specific linear model. So each store has a linear model on the last quarter time series or last year time series. And then the linear model is trained on the day number, day of week, and promotions. And then you train a linear kind of model and then forecast into the test set. So if there's the increasing trend or decreasing trend, and hopefully the linear model can capture that. So, and then there are also other features, such as the features from the store metadata, such as assortment, type, and also, of course, you can do another round of aggregates by store, right? So from that sales data, you can calculate what's the average sales per customer, and and then the ratio of sales during the promotion, like if there's a promotion, holidays, and and if it's a weekend, and then what's the sales kind of, it must increase, right? And then how much increase of sales during these events. And then also for each of the store, what's their proportion that there's holidays, and also the days that the store is open. And then there's the state-specific weather, right? So I think this is not provided by the competition, but they get some external data on the temperature of max temperature and precipitations in that. Because I think if it's a bad weather, of course, the sales will decrease according to the bad weather, right? So, and of course, to forecast into the future, you also need some reliable weather. So I guess they use some more of the historical weather there. but it's very hard to, I think, forecast the extreme weather for the future days, right? So yeah, but I think they find, or some other participants find it somewhat useful to incorporate some of the weather there. And for the modeling, they just use one model, the GBM models. So for those who are not familiar with it, this is just a very simple, straightforward way to illustrate what's a gradient boosted trees. So basically, you just first train one tree in the beginning, and then you just fit the data, and then you calculate the residuals from the data, right? And then the residual is what your next tree is training to reduce, right? So and again, you get another round of improvement, and then you fit the residual to the third tree. So it's kind of an iterative way to train the trees to reduce the errors or reduce the residuals from the last round. Yeah, I think this is the most, this is the must-have. It kind of becomes the must-have model in the winning solutions, no matter like if they don't ensemble or if they use multiple models, or if they use just one model, almost every winning case has a GBM there as one of them. Yeah, so for the model training, they just use XGBoost. And then because the author says they generate lots of features, so they need to do some feature selection. So they just train the models on a random selection of features, right? So and of course, he also handpicked some models where he thinks makes sense. And then basically he trained 500 random models, and then also validates on each pair of the ensemble model. So they just like choose 2 of the models as pairs, and then and validate the results on that. And then they find the best models, and then they take the features from all the best models and then combine into one. So this is how they do the feature selection. Well, I think it's a little bit too overcomplicated, but they find it this way. They're able to like kind of improve the performance, like kind of doing the feature selection and model ensembling at the same time. Another trick they do is they separate models on the months from May to September. I think this time period covers the dates in the test. So they kind of specifically focus on the dates that exist in the test model. So they train a separate models on that. And then they also train months ahead models, like train, for example, use the for example, using the months like January to March to forecast May, for example, right? So you can directly predict like months ahead models using the historical data. And then because they log transform the variable. And then in the end, after transforming back, they find applying a multiplier factor of this will improve the performance. I think this is also very debated or discussed on the discussion forum of what factor to apply. And actually they'll also apply a 0.99 to get the first place, but later they find out someone suggests a more kind of a theoretical value of 0.985 to even further improve their performance. Yeah, so as I would say, this is just a magical number over there. And people find that like applying a multiplier factor to adjust the number after the log transform back, it will improve the performance. Yeah, so this is the results. So the without feature engineering, they said that the improvements are nearly, very small. I mean, small meaning like with the feature engineering, the improvement is not that great. Like without feature engineering is the black one, and with the engineering is the red one. So the red kind of improves a little bit on the black, but they can the Kaggle leaderboard. Well, you can just increase by like a lot, just increase your accuracy by 0.005, for example. So I would say you really need some luck to get to the top 10 or top first place. Although from this chart, what we can tell is without that much feature engineering, we already get a very good enough result with the XGBoost model, right? But I think from this winning solution, I think it gives us a very good inspiration of what features can be extracted for your task. Okay, this is one solution. Do you have any questions before we move to the next one? Okay, let's move on to the next one. So the next one is a third place solution, but I think I like this one a lot. And they also published a paper on that. I think back then the entity embedding is still not that popular, but they apply the entity embeddings for all the categorical features. And then they find out that actually the entity embedding can improve any model if you just use the embedding rather than additional values. So what is entity embedding? Well, you can think of it as the dimension reduction or as the compressed information for the features. For example, the store ID is lots of IDs, and originally it has over 1,000 values. And then throughout the entity embedding, throughout the embedding layers, you can end up with the 10 dimensions for that ID, right? And then for each of the features, you can greatly reduce their dimension to below 10 over here. So, and then after you extract the embeddings, then you can combine them with any methods, such as the KN, random forest, or any type. And then you can see that with the entity embeddings, they greatly improve the performance. That's what they find out. Over there, like even with the gradient boosted tree, with the embedding features, you can also greatly reduce the errors there. So the two tables, they show two tables. Well, the first table is on the shuffle data. So it's not, you just randomly select 90% for train and 10% for test. And this is a little bit, I would say, not fair for the time series, right? So you need to split the data based on time. So the second table is kind of split the data based on time. So the test is the latest 10% of the data. So this is a more fair evaluation for the time series. Yeah. So this is the Rossman score competition. So because it's 6 years ago, so I would say the competition, you can see the solution is more focused on the features a lot, right? And then later, as you see, as we move on and more models are assembled, and also more and more neural network get used over there. Okay, do you have any questions about the first competition or any thoughts, comments?
Hi, yeah, I actually have a question about the entity embedding. How do they do the entity embedding? Do they use like language, natural language processing or something else?
Yeah, I think they, yeah. So in the TensorFlow, you have the embedding layers, right? So, so they basically, I think right now it's much easier to do the embedding, but back then they still need to one hot encode the variable, and then they input it into the embedding layers, and then concatenate them together through a simple neural network to predict the cells. And then they just use the output from the embedding layers.
Okay, thank you.